Now on the previous video we looked at domain and range. We just looked at a few points and how to determine the domain and then how to determine the range, right? Now usually you're not gonna find just those few points. You're gonna actually find a graph. Okay, for example, this on its own is a straight line graph. This one, it's a what? It's a straight line graph. All right, so it will be looking like this. It's going to have an arrow here, right? And then it's gonna have an arrow there, right? So now the question would be, what is the, it could be FRX or it could be GRX or the likes, right? Now the question is, what is the domain of this function? What is the range of this function? Okay, so this is a straight line function, eh? Now a straight line function has a general formula: y is equals to mx plus c. All right, this is your straight line that you learned in grade 10, 11 and 12. So now how do you find its domain and then how do you find the range? Well, for the domain, remember in the previous video what we were doing is that we were listing our x values. We were saying this is a starting x value, here is -2, the ending x value is 1. We moved from left to right. So I want you to tell me, when you look at this graph here, right, when you look at this graph here, which one is your starting x value when you move from left to right? Remember, this is the left side, then this is the right side, right? So when you move from left and then all the way to the right, which one is the starting value? Look at this line here. Which one is the starting x value here? Right? There is an arrow here. What does this arrow mean? It means this graph doesn't start here. It actually goes further up until negative what? Infinity. Meaning, remember, if I look at a point here, there is an x value, right? If I look at a point here, there is an x value, right? So which point has the first x value? Is it this point? No. Is it this point? No. Is it this point here? Because it's gonna have an x value. No, the arrow says there are other points that are not shown, meaning here there is also a point with an x value. So we cannot tell which one is the x value that is starting. So this thing, that's why it goes up until negative infinity. It tells you that there are many other lines that are not shown here. So it goes until negative infinity, and each point is going to have an x value. Each point is going to have an x value. So it's hard for us to know which x value do we have first. So what we do is that we're going to say x is an element, and then we say the x value that we have starts at negative infinity. Now we use a round bracket. Do you see that the x value starts at a negative infinity? And then we then say, all right, sharp, what about on the right? Which one is the last x value? Is it this point here? Is it 5? No, there is another point here. Is it 6? No, there is another point here. Is it 7? No, there is an arrow. It says this thing goes on up until what? Positive infinity. So is it this point here? Is our last x value 9? No, there is another point. You see, there are always going to be another point, another point. So it means our x values, they're going to end at positive infinity. Okay, at what? At positive infinity. And we don't know what will be that x value. That's why we use these round brackets there. So this is the domain of a straight line function. Okay, what about its range, right? What about its range? Well, I'm gonna have maybe to redraw it again. Now let's try and redraw it again. Let's say this is our graph there. We were talking about it and saying it is FRX, eh? It is FRX. Now I want you to remember, for the range, range is the collection of y values. I must say y is an element. Now where do my y values start? Do they start on this point here? This point has a y value. Do you see that? Is it the first y value? No. Remember, we move from down to where? Up. So we move from down upwards. So we look at each point and then we go up. So which one is actually the first y value here? Is it this one? No, there is another point here. No, it can't be this one. There is an arrow. This arrow says this thing goes until infinity. There is a point here. Is it the first y value here? No, there is another point here. Is this the first y value here? No, there is another. You get what I'm saying? So it means this thing, it starts at the y value that we are looking for. It's at negative infinity. Okay, so it means this thing starts at negative infinity, and then we want to go up now. So which one is the last y value? I get this the first y value at negative infinity. Which one is the last y value? Is it this one here? Is it close to 1 there? No, there is another point here. Is it 1? No, there is another point here. Okay, then is our last value 2? No, there is another point here. Is this our last y value? No, there is an arrow. It tells you it goes up until infinity. There is a point here. So it means, is 4 our last y value? No, there is another point here. Is 5 our last y value? No, there is another point. So it means this thing ends at positive infinity. Okay, this thing, it means it will always have points, and then our last point is going to have a value at positive infinity there, right? So that's the range. I hope that makes sense. Okay, so that's how we get the domain, and then that's how we get the range. Okay, now this would be the last function for this video. Okay, let's say you have the following here. Let's say you have the following here, this graph here. Ooh, it's not that beautiful, eh? It's really not that beautiful, but yo, it's really ugly. I'm so sorry for this. I'll try it better next time. What is the point here? The x is 0. Remember, x, we look at the x-axis. The x is 0. What is the y? We look horizontally. It's negative 3. Okay, so what would you say is the domain and range of this graph? Okay, so for the domain, we're gonna say x is an element. Which one is our starting x value? So remember, for the domain, you're going to be looking at your x values, right? Is this our first? Look at this point. Is this our first x value? No, there is another point here. Is this our first x value? No, there is another point here. Is this our first x value here? No, the arrow says this thing goes until what? Until negative infinity. So it means this point will also have an x value. Is that our last point? No, there's another point. There's another point that has an x value. There's another point that has an x value. There's another point with an x value. So it means our x values, they're gonna start at negative infinity. Okay, because we can't tell which number it is, because these points are going all the way to negative infinity. Then look at this one here. Now that this is the starting, where do they end? Which one is our end? Our last x value. Is it this point here, because we see an x value there? No, there is another point here. Is it this one? No, there is another point here. So is this one our last x value? No, there is another point here. Is this our last x value? No, there is another, and there is an arrow. It tells you there is another point here. Is this our last x value? No, there is another point here. Is this our last x value? No, there is another point there. Up until positive infinity. So it means our last x value will be at positive infinity. Because the moment you choose a point and say this is my last x value, there is always going to be another point. So it means our x values, they end at positive infinity. What about the range? What is the range of this graph? Well, to find the range of this one, remember, for the range we move down to where? Up. Okay, so we start on the first point, down. This is our first point on the graph, right? On our first point here, y is an element. What is the first y value that we have? It's negative 3. So it means our y values, they start at negative 3. And is there a hole? No. Is there vertical asymptote? No. Horizontal asymptote? No. Infinity there? No. So we use a square bracket. Then we say this is the start, right? Where do the y values end? Which one is the last y value? Is this one our last y value? Because we see a y value here. No, there's another point here. Okay, is this one our last y value? No, there is another point here. Okay, is this one our last y value? No, there is another point here. Is this one our last y value? No, there is another point there. And up until infinity, it means our last point with the y value, it will be at positive infinity. That's why we say this is the range of the graph. I hope that makes sense. All right, and then I'll see you on the next one.